Right, so this one, that the video actually ended in the first one. So this one again, 25% duty cycle, as I've said, 0 to 255, and this one is under this one, this range. This 64 is under this range, so 64 is coming. You can do the voltage conversion if you want. It's not a necessity. You can just work with these values. Even the duty cycle is actually not so important. uh, like, just for knowledge, I'm sharing this with you, because in future you can work with pulse width modulation on your own with this knowledge. All right, you can also if you know how to use these numbers, then that will, I guess, be sufficient. Now what I'll do is stop the simulation and then go to the calculator here. So suppose I want the duty cycle of 50%. Okay, again, the duty cycle percentage that I am talking about, 25, 50, 75, it's not necessary that you have to use these three only. You can even use 20. You can even use 1% duty cycle. It's not a problem. Now what you'll see here, all right, so 255 divided by 2. So this is 50% duty cycle. We'll just round it off to 128. Okay, so here we'll round it off to 128, and you'll immediately see the change in the oscilloscope. You can see the thickness has increased. Before it was this much, that is 25. Now it's this much has been added. So in total, this is 50% duty cycle. And again, 0 to 255, the range. This is the range, and 128 is under this range. So this is 50% duty cycle. Now you can imagine that 75% duty cycle would be this much. All right, now I'm not going to leave the I'm not going to change the annotations here. I'll simply uh, do the conversion here. So to get 75% duty cycle, what you can do is 255 into 3 equals divided by 4. This is the 75% duty cycle value that you are seeing. That what I was doing is that 75% basically means 25% in plus 25% plus 25%, right? So 25% already we know that it's 64, and so 255 divided by 4. So this one, and we need three times 325s. So into 3, 191.25. So let's use 191. 191. Now see the change in the oscilloscope. Can you see that now it has been, it's working on the 75% duty cycle, and this marking that I'm giving here is 75% duty cycle. If I give a 100% duty cycle, it will just give us one straight wave, and I'll just use 255. All right, and 255, see here you were getting a straight wave. This is just the high. All right, now you can see that it's a constant wave is being produced, and there's no change in pulse or anything. You cannot see any square waves. You can just see a line, and this voltage level, although it's showing, I don't know how much it's showing, but it's actually oh yeah, sorry, the we are working on this voltage level, right? So yeah, so this is correct only, there's no problem. All right, so this part has been done. Now what, like, I have another explanation for this one, and it's for an easier explanation. Let me just check the time. I have 5. Okay. Mm, Here, sketchbook. All right. I'll just remove this, and then okay. So what happens with this? You've now understood what duty cycle is and all. Now I want to explain it in a more easier manner. Okay, so let us take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this to be circles. This points. This is not 60, 70, 50. Just these are just points. Alright. I have no idea how to use a different color actually. Let's see how. Just to change, so that you guys don't get confused that it's a number or a point or something. Alright. Now at 10% duty cycle, I'll write it here. 10% DC or duty cycle, not direct current. Alright, this is duty cycle. The direct current DC is different. I'm just using short form DC. At 10% duty cycle, let's keep it this blue. This one line will only pass. Why, you were asking? Because 10%, as I've explained in the first video, 10% duty cycle means it is only on 10% of the time. Rest 90% of the time it is off. So although this is not exactly how it works, but just to explain you guys, see, this 1 represents 1 ampere. Alright, this 1 ampere, this 2 also represents 1 ampere, and in total this thing represents 10 amperes. So hence I have taken 10 points here. Now 10%, only 1 ampere current could flow through the transistor when the the switch is on. Because the switch was on only for 10% of the time, so it could only flow, only 1 ampere could flow. Now if I'm changing the duty cycle to maybe 40%, let's take 40% here, or let's take 50%. Let's suppose I take duty cycle as 50%. What will happen is that this 1 ampere current will definitely flow, but this one, another one, another one, and another one. Now 5 amperes current is flowing, not 1 ampere. Why? Because 50% of the time the transistor is in on, the transistor is on, and the rest 50% it is off. Okay, so 5 ampere current is able to flow through, but this rest 5 ampere is not able to flow through because the remaining 50% of the time transistor is off. Now if I suppose take a duty cycle of 80%. Now by thinking that you guys have understood properly, if I use 80% duty cycle, that means that this 1 ampere will go, this one go, this one will go, this one will go, this one will go, next one will go, next one will go, and this one will go. So 8 amperes are now going. Alright, but the main thing is that in this 10% duty cycle, the voltage level was 5. In this 50% duty cycle, voltage level is also 5. In 80%, voltage level is also 5. What is changing is the switching, the time the transistor is on and the time the transistor is off. So less time transistor is on. If the transistor is on for less time, 10% working time, then here, this is just an example. This is not exactly what's going on there. Just to ease the explanation, I've used this. So 5 volt 1 ampere is going here, and then here again 5 volt 5 ampere is going in case of 50% duty cycle, and then again 5 volt 8 ampere current is going. Alright, this 5 volt remains same, it does not change. This current flow through the transistor is actually what's changing. The transistor is allowing more current to flow in that time. Now you might be still confused. I have an example.